Today we are talking about object-oriented programming. This is the subject of our class in general. Our laboratory works and lecture devoted to it. There are 4 principles of OOP. You have to know them, and which is more important, understand how to implement all these principles in your code. So abstraction, inheritance, encapsulation, polymorphism. Abstraction is a principle when we have some data type and we can separate some more general of few data types, and we can separate some more general properties of all these classes in one parent class, and in this case we will reduce the amount of properties in child classes in our hierarchy. Inheritance, that's also about properties in a parent and in a child class. Encapsulation, it's the property which allows us to hide some behavior or properties of created object from outside classes, methods, and etc. Polymorphism is ability to change behavior of a parent class by a child classes. When we build some hierarchy, we also have a relation and the relations between these classes, and these relations could be different. In general, relations between classes could be inheritance and association. So we have 2 classes and they associate one to another one. But inheritance is one of the ways to build dependency. Association is another one. Association is less strength way of relation. Aggregation has higher strengths. Composition is higher than aggregation. In a few words, if we create from practical point of view association, aggregation, and composition, it is creating some class which is dependent on another one, which we instance of which we create inside this class. This is like inheritance, like a relation between a sheep and save life board, which is connected with the sheep, because this board can you can move with this board without any sheep, so this is like association. But also this board could be on a sheep. Yes, also if you're talking about engine or some parts of our ship which are very strongly connected to our ship, we are talking about composition. Aggregation is somewhere between them. And solid are the general principles of building our programs. Unified modeling language is a language which allows to do at first drawing or some sketch of your program with some primitives, graphical primitives, and these primitives are unified. And with these primitives you can draw the prototype of your program, and there are some tools which allows you to generate code based on this sketch. In this Wikipedia page you can see multiple different unified modeling language tools. We tried to install them in Eclipse environment, but unfortunately few of these tools are broken. Some of them are not compatible with our version, and some of them needs payments, so we skip them. And also from these tools, the working tools, I know that they work properly for Java, especially for Java, are NetBeans. It works, really works. And also I know that works and it's free. Also Umbrello. Umbrello is a very nice tool. It's suitable for multiple programming languages. There are some disadvantages of this program, because there are some incompatibilities with Java, because it's more general. So it's not incompatibilities, but you have to do some additional manual work after generating this sketch, and this sketch generate code. So what you are doing, you are creating class diagram, for instance. You are creating class diagram, and then what you are doing, you simply generate code, because you have here ability to code active language. You send language which is active for you. You see that we can create C++, Java, JavaScript, Object Pascal, or etc. We set active language Java, and we can create class diagrams. Yes, I create class. It could be vehicle, and vehicle could be tractor, and it could be bus, it could be car. Also you can build some dependencies between them. This is inheritance, and we have parent class vehicle, and we have children. We have children. We have child tractor, we have child bus, and car. So we can implement them. Also there are packages here, something which called packages, and also we have something which called composition. We have aggregation, and we have containment. Also there is dependency, multiple dependencies, yes, and generalization. You also see this. This is inheritance, if some child inherit some parent. Also we can add here package, and package contains multiple classes. For instance, it could be something like it's a package. Package contains multiple classes and also packages. So this is the idea, and also we can generate the code. Active language is Java, as I told. We can code generation wizard. We set Java, yes. We set the output directory where it will be generated. We set some formatting which we want to have. If there are some options, we add also them here. And next, class is selected, next, generate, finish, and now our code is generated. We can look UML generated code, and what we will see now. There are multiple different classes here, but if we look here, we see bus. It is generated today, yes, car. So bus, car, tractor, and vehicle. So these classes are generated today. Before, we also with the students generate these classes. But if you look inside this class, you will see some code which you can use for the steps of development. So you created some sketch, and now you see how look like your idea of your code. Also in Umbrella you can draw use case diagrams, sequence diagrams, collaboration diagrams, state diagrams, activity diagrams, component diagrams, deployment diagrams, and entity relations diagrams, which are not UML. We will talk about strictly about UML. So 1, 2, 3, 4, 5, 6, 7, 8. 8 diagrams are UML diagrams. This is about databases. But also it's this tool is free, and you can use it for your own purposes. So this was Umbrella, and also today we tried to draw our hierarchy. It was vehicle, and what is important, we create more general class. That's what about abstraction? We create more general class. You saw that we have generalization, yes, in Umbrella, and also here we have generalization. Vehicle is more general than automobile. Car is less general than automobile, and truck is also it could be a car, or it could be yes, it is a car. So this is small hierarchy of classes and interfaces, and now you see that, and you know that this sign means inheritance, and this is where this arrow pointing is a parent, and these are children's. And now from the left part you see some description language. This is not Java, it's description language of our class. And what we can do, we can also generate it, Java code, generate it, and we also have a code. So from this code we generate this code. Unfortunately, this environment doesn't support multiple features of Java. Only general features are supported, so I can't recommend it for you. But in general, to get main ideas, it's enough. So the task for you will be select some subject area or some domain, and select from this domain classes and build your own hierarchy which you will implement in a program. So the task for today for you will be, please create your own program, not a program maybe, your own design of some program according to OOP style, like I explained for you now. For this purpose you can use any visual editor which you prefer. Draw.io. You can use Draw.io, and here you see class diagrams also create, and you create a class diagram here. So Draw.io also very good program for our purpose, but it's only for drawing. It doesn't allow you to generate a code. This is disadvantage of this tool, maybe. So you cannot generate code according to this diagram, but you can make drawing for this class. It's enough. For this class, that's enough. So please try to make some hierarchy of classes, and please choose some subject area or domain which you are interested in. It could be animals, it could be cars, like in our example, it could be computers, it could be hierarchy of some students, of plants, or what do you prefer. So here you see also inheritance. Person is a parent for student and a professor. Both of them have properties: name, phone number, email address, and has person has also purchase parking pass. And this is behavior, the behavior of this class. So a student and a professor are also have this behavior and have this has this properties like a person. Student also has these properties, and also additional methods. And also this is association. This is connection between address and a person. Address and a person. This is connection one-to-one, because person lives at address. That's like in a database when you build entity relation diagrams for databases, but this is a bit different, because here we are talking about program structures. So you create your own data types for your programs. So this is very also good option for creating diagrams for your laboratory work. So this is small introduction to object-oriented programming. And also, if you look Princeton, we also have OOP, and we also have using data types. Yes, some ideas of OOP. I believe using data types, creating data types, designing data types. But it's more close to some algorithmic tasks. So I suggest you to first start to imagine and find out domain which you are interested in.